Welcome to the course Digital Transformation and Technological Innovation. So, we are into our fourth module, that is Tech Advancement and Internet Basics. Especially we were talking about the internet part of it. So, let us continue our discussion from where we left in the previous session. So, we were talking about the dominant architectures for distributed computing implementation on top of internet, and we were discussing the second one, that is microservices architecture. So, some of the attributes of microservices architecture we covered. Now, let us look at a higher level how this architecture is maps into different aspects. So, first important aspect of microservices architecture map is that service discovery. So, how service discovery is done? So, it is handled via service registry. So, there are dynamic registries, for example console or Kubernetes DNS, that track live container IP addresses. So, because we are talking about the microservices architecture, we are into earlier in the cloud discussion, we talked about the containerized applications. So, essentially we are more often than not in the cloud context whenever we talk about the microservices architecture. So, service discovery is handled via service registry. So, services are registered and dynamic directories track live container IP addresses, right. So, therefore, that tracking ensures that service is discovered. So, that is the main mechanism for service discovery. Then we can talk about the another aspect of microservices architecture map is data consistency, right. So, data consistency, how it is handled? It is handled by event driven sync, right. So, asynchronous event broadcasting to achieve eventual consistency across services. So, eventual consistency is the defining feature here. So, asynchronous is event broadcasting is aligned with that goal, right. So, asynchronous event broadcasting across services is actually something that is done to achieve eventual consistency. So, service discovery and data consistency. So, these are two elements that you would see that if you compare with the client server architecture, they are different, right. Now, next important aspect is network latency, how network latency is handled in case of microservices architecture, right. So, that is handled via API gateway, right, and a single entry point is there, that aggregates backend microservice requests to minimize client side latency, right. So, this API gateway and this single entry point that is there. So, that helps in terms of managing the backend microservices request, and overall latency at the client side is minimized because of this approach. Next is observability. So, observability in the sense, if there are any issues, if there are any problem in the in any of the microservice or any other aspect here, what is the mechanism to address that. So, the observability of the whole services, the whole application distributed computing implementation is handled via distributed tracing. So, what it does, it injects unique correlation IDs into network request, and that allows it to track logs across all nodes, right. So, across all nodes that are there, the logs are tracked, and a unique correlation ID is injected to be able to do that. So, distributed tracing is implemented to ensure the observability in microservices architecture. Now, if we look at the microservices architecture summary, so it supports both synchronous and asynchronous communication. So, in case of client server, it was just the synchronous, right. So, microservices architecture supports both. So, therefore, it works for more varied kind of application scenarios, more varied kind of information systems, right. And so, communication, synchronous and asynchronous, coupling, as we talked about, loosely coupled, right, that independent microservices concept. that is achieved, and that indicates a loose coupling there. Primary benefit is team agility and independent deployment. That is something that that is one of the main benefit of this, right. So, we already talked about how in the previous session that how the single server side problem of client service architecture is handled by the microservices approach, moving away from monolithic to microservices. So, this independent deployment and team agility becomes the primary benefit because of that. But if we look at the drawback, now the same network that is supporting the microservices architecture, the same approach now becomes more complex for debugging, right. So, complex network debugging, because if you look at that service discovery, there are dynamic directories and the tracking is there for container IP addresses. So, in case a container goes down, and then if you want to do some sort of debugging for that container, why it went down and all that. So, that becomes complex. So, debugging is one of the drawback of microservices architecture. Now, we move on to third dominant architecture that we talked about in the previous session, event driven architecture. So, with the advent of 5G and lots of streaming services that are there, event driven architecture is something that has become dominant, and so it provides a coordination framework to allow networked machines to collaborate without waiting for one another, right. Because event driven architecture, there might be lots of client machines, and streaming might be reaching them at different pace because of the network and bandwidth issue is there. So, how do you coordinate in that case, right. So, event driven architecture creates a or provides a coordination framework to actually match this situation, allow network machine to collaborate without waiting for one another. So, sort of that dependence is taken away, and the coordination is then becomes feasible. So, therefore, temporal decoupling is one of the defining attribute for event driven architecture. So, what happens in temporal decoupling? Nodes simply broadcast an event to a central message broker. So, there is a central message broker which plays an important role in terms of making these machines collaborate without waiting, right. So, nodes broadcast an event, and that gets recorded to central message broker, and then those nodes immediately move on to their next task, right. So, essentially this central message broker it tracks everything. So, therefore, it facilitates this temporal decoupling. So, nodes broadcast and then move on. So, that kind of temporal decoupling is possible because of the central message broker. Now, the message passing as such, it follows more like a publish subscribe model, right. So, what happens here at a higher level, nodes connect to a distributed event log, right. This distributed event log can be managed by like Apache Kafka or AWS Kinesis, right. So, these kind of distributed event logs nodes can connect to. So, essentially this is more like a publish subscribe model. What kind of event nodes are subscribing to, and therefore, the masses they will have access to those messages, and therefore, they will be able to coordinate, they will be able to collaborate and coordinate without having any dependency on others. Another important attribute of event driven architecture is horizontal scalability, right. So, event driven messages, they queue asynchronously, and that allows consumer nodes to actually ingest and process data at their own pace. So, because things, there is a central message broker, and we talked about the distributed event log that nodes are connecting to. So, because of that consumer nodes masses are queuing up there. So, consumer nodes get the flexibility to process at their own pace. So, different consumer nodes might have their own varied computing workload and varied computing capability, and because of that this architecture, different kind of devices, different kind of consumer nodes, they can ingest and process data at their own pace. So this gives horizontal scalability across so many different kind of devices, client devices, right, that might be or the nodes, consumer nodes that would be connecting to the service. So that horizontal scalability is there because of this asynchronous mechanism that is there, right. So this becomes another important attribute of event driven architecture. Now another aspect of horizontal scalability is that whenever, let us say, there is a massive traffic spike, those are occurring. So if there are occurrences of massive traffic spike, so how they are handled, so there are lots of temporary worker nodes are there, which are actually spinned up, and they become online, and they start to pull events from the queue. So that queue that is growing up, so these worker nodes, because there is a spike, so to avoid the too much of delay, these worker nodes they become online, they are spin up, and then they start pulling events from the queue, and start processing that. So even because of this scalability, overall the system is not overwhelmed, and whenever these spike occurrences are happening, these temporary worker nodes they kick in, and they start pulling events and start processing them, start processing the queue, event queue. So this is how the horizontal scalability is managed. Now another important attribute of event driven architecture is that reliable network, right. So distributed event brokers, what they have, they use persistent replicated logs to guarantee delivery. So those logs become important in terms of providing a reliable network, right. So the event that is being processed, because of those persistent replicated logs, each of the devices, they would be still can be guaranteed delivery, if even if because even if they are, as we talked about, they might be processing at different speeds at their own pace, right. So this own pace thing is possible because of this, because there is a persistent replicated logs. So always that can be used to guarantee delivery, right. And in case there is a mid operation crash of some node, then also the event remains safely stored in the distributed cluster. So whenever that node comes up, that consumer node comes up, it can pretty much safely resume from there, because that information is there stored, the event information is there stored in the distributed cluster, right. So that is what is mentioned. Post recovery, machine can resume reading the event stream exactly where it left off, preventing data loss. That means all the client devices, all the machines, consumer nodes which are connected, they can pretty much, if they crash, still they will be able to resume from the same place, because everything is asynchronous. So all devices are running at their own pace and able to process data as needed. So there's a reliable network, horizontal scalability, right. All these become important defining feature or defining attribute of event driven architecture, and why it works well, right. So post recovery, a machine can resume reading the event stream exactly where it left off. So the this architectural attributes that we are talking about, that you can pretty much visualize whenever we are watching any sporting event over the internet through different OTT apps or YouTube, right. So what is happening, different people are might be different people might be using their own smartphones or other computing devices, but they are able to watch at their own pace. So how that is possible? Because of this architecture. So all, whenever we are watching a live stream, essentially event driven architecture is giving us the experience, the independent experience that each end user is having, right. Now if we try to map this out, if we try to map out the event driven architecture, so one important element is data synchronization. So data synchronization approach is that eventual consistency, everything is async. So, if you recall, we discussed the microservices architecture. So, they are also asynchronous coordination element, both synchronous asynchronous are there, and in the asynchronous part the same concept was there to be able to achieve the eventual consistency. So, here event driven architecture is purely asynchronous. So, data synchronization handled by eventual consistency. Nodes, so what happens? Nodes update their local databases by continuously reading and reacting to the global event stream. So, the global event stream, they continuously they are reading and reacting, and that is how nodes are managing their local databases, and that is how this asynchronous thing is working. And if we look at another important element here is the network backtracer. So, that the log that is getting generated, because every node is going at its own pace. So, this network backtracer is handled via log buffering, right. So, the event broker acts as a SOC absorber here, because it keeps all those events there, just like absorbing all the SOCs, all the events, right. So, the devices can pretty much keep on reading from the event broker and reacting based on that. So, event broker acts as a SOC absorber, and it safely holds millions of messages. So, whenever client all the client devices, all the consumer nodes, they can go with their own pace, and the event broker is holding all the messages, millions of messages, right. And so, when downstream nodes are overloaded, the event broker is actually will be absorbing all the SOC, right, because those messages will start queuing up a lot. So, and if there is lots of delays and there across downstream nodes, then it is the event broker that is absorbing all that all those delays there. So, this network backtracer is an important defining feature and that is handled by the event broker. So, another element of event driven architecture system extensibility, right. So, how because streaming and all those things are happening. So, this actually needs to be handled. So, it is handled by via zero impact integration. So, whenever there is too much of load, then what happens, new distributed nodes can join the network and subscribe to existing event streams without altering any source code. So, because of that this extensibility that whenever there is too much of load, new distributed nodes can join, and there is that kind of extensibility is there. So, there is no zero impact integration. So, they do not have to worry about integration and all that. The architecture is designed in such a way. So, this also becomes a defining feature, and that is how those live streams as the load number of views are changing or fluctuating. So, the system extensibility feature is providing that that is scalability that is needed in this kind of architecture, right. Now, we try to summarize the event driven architecture. So, essentially as we talked about, the communication part is purely asynchronous, right. So, if you recall the microservices architecture, right, microservices architecture was synchronous and asynchronous both, and the client server architecture was mainly synchronous. So, essentially you can think of the kind of applications that are possible with the client server architecture. So, it has to be applications should be aligned with the synchronous synchronous feature of the client server architecture, synchronous only feature of the client server architecture, and both kind of things are needed for a application. And then the microservices architecture might be more suitable because it supports both synchronous and asynchronous. But if there is an application is more like asynchronous only, then event driven architecture might be more suitable. So, communication is purely asynchronous, and coupling is completely decoupled, right. So, the live streaming is happening real time, but the consumer nodes they can process at their own speed. So, there is no coupling as such, not even the loose coupling of the microservices architecture. So, we are moving away from client tight coupling of client server architecture, where everything is like all the whole communication is very tightly coupled. It has to be done, only then we move to next step. Microservices architecture, loosely coupled, right. So some of that is the synchronous part is would be tied, and the asynchronous part is would be slightly loose. So therefore overall slightly decoupled. So therefore overall thing in microservices is loosely coupled. But in case of event driven architecture, the coupling is completely decoupled because the whole scenario is asynchronous. Pure asynchronous coupling is completely decoupled. Primary benefit is extreme scale. So crores of devices can actually connect to a a service, a streaming service on top of internet, right, and that that extreme scale is very well supported by this architecture, and real time processing is happening, right. So the streaming is real time, and for many devices which are having good connection, good connectivity, they will have that real time streaming at the end user side also. So end user will also see the real time action happening at their device, but other devices which are slightly slowest, they will also be supported and slightly delayed kind of real time, slightly delayed kind of streaming that will be there. So extreme scale and real time processing is supported. Main drawback is eventual data consistency delays, right. So because of this as purely asynchronous thing, there is nothing that is actually being synchronized there. So because of that, one might notice that sometimes the data consistency, eventual data consistency, that gets delayed. So that becomes a drawback. So much of delay across so many devices, so that remains drawback. So if there is a service where this is not desirable, then maybe event driven architecture is not something that is not suitable, right. So client server architecture, microservices architecture, and event driven architecture, all three have their own pros and cons. So client services architecture is more useful where when there is something that is to be guaranteed and you want more control, and when microservices architecture sits in between, where much more much more scalability is there, both synchronous asynchronous part are there. So more suitable in that context, especially in the enterprise context, cloud computing context, right, where microservices is much more suitable. And if there is something that is guaranteed in those enterprise contexts, the client server model is more suitable. And event driven is more suitable for streaming, which is more related to entertainment or sports, where the guarantees thing is not really that much applicable. So therefore but real time processing is something that is much more meaningful. So event driven architecture is much more suitable in those situations. Now moving on, now if we look at the client side distributed computing, so this part of the at the client side, actually what is happening is human computer interactions are being handled. So client side distributed computing, the workload, and for example user inputs, right, and triggering service or API requests. So this is actually the client's machine processing power is actually used. So this is something that we talked in a previous slide also. So all the human computer interaction and the computing that is needed for that happens at the client side, right. So via browser or app user interface, right, and it is the client machine's processing power that will be used in this, right. Now moving on to human computer interaction. So what are the different elements of human computer interaction, how end user is experiencing a particular application delivered via internet, irrespective of the architecture, three dominant architectures that we followed, right. So whenever an end user is interacting with interacting using client machine and client software, and some human computer interaction happens, so end users will be looking for a resource, right. So they need to identify a resource on the internet, and how do we identify a resource on the internet? So there is something called URL, Uniform Resource Locator. So, this is more like an address. So, whenever we are looking for, let us say, a live streaming of a sport event, so we need to specify an address in the web browser, right, and that address is actually the URL, Uniform Resource Locator. So, we want to identify that streaming resource that is there. So, end users, when they interact, when they do when we talk about the human computer interaction here, the human part, the end users, when they interact, they need to specify or identify the resource that they are looking for, and that address is referred as, the address of that resource is referred as URL, Uniform Resource Locator. So, it is like an address to the resource on the internet. So, where that resource is actually hosted, and Uniform Resource Locator will actually have that information. So, this URL is typed into an internet browser, and now if we look at the URL, what is there? So, it consists of multiple elements which are separated by delimiters like dot, semicolon and slash. So, URL has its own composition, and then put together it is used to identify a resource on the internet. So, at the end user side, the kind of human computer interaction is happening. First thing, you need to specify an address for the resource on the internet, right. So, in this session, let us do a quick recap of what we covered. And so, we started with microservices architecture, mapped out certain high level points of microservices architecture, for example, service discovery and how that happens. There are dynamic directories, and then the track, live container addresses, and data consistency is there. There is asynchronous broadcasting that is there. So, event driven sync is there for data consistency. Network latency is handled via API gateway. So, there is a single entry point, and that will be aggregating all the microservices requests that will be coming in, and that is how the client side latency will be minimized, because the load would be balanced. The single entry point will be able to distribute the microservice request in such a way that the latency at the client side is minimized. So, the single entry point is there, right. So, the API gateway, this has similarity to some of things that happen at the client server architecture. And observability we did talked about, that is another attribute. So, there is distributed tracing there. We look at the summary that microservices architecture has both synchronous part, loosely coupled and all that. Then we talked about event driven architecture, and we talked about temporal decoupling that is there. So, different devices can be connected to services with different time stamps. And temporal distance is manageable, because asynchronous kind of communication is happening in the event driven architecture. Publish subscribe model is there for distributed event log. Horizontal scalability is there, because the messages are handled asynchronously. Spikes can be managed through the temporary workloads, which can be quickly added up, right. Reliable network, because persistent replicated logs are there, so guarantee for the services there, right. So, and then everything is stored at the distributed clusters. The events queues is there. So, even if there is a crash, the post recovery is possible. Then we looked at the mapping of event driven architecture, that is data synchronization, network backtracer, and then we talked about system extensibility. So, all these are the defining features for the event driven architecture, and it is purely async and completely decoupled, supports extreme scale real time processing that we see in streaming services, right. And then we started our discussion on client side distributed computing, so which will continue in the next session. We started talking about the URLs. Thank you.